Alright, so we're continuing with multiplying and dividing rational expressions. Now we're going to talk about division. So again, we're going to take a step back, and we're going to figure out how to, or remember, how do we divide fractions. And then we're going to apply that same idea because rational expressions are just fractions, but there are polynomials in the numerator and the denominator, or both. Okay, so if, the rule is if we want to divide a fraction, we want to multiply by its reciprocal. So what I'm going to do is I'm going to take this expression, okay, and I'm going to flip over the second term only. Right, so again, multiplying by the reciprocal of the second term. So the first one stays the same. Okay, this one's going to turn into 25 over 18. Okay. And then I'm going to proceed like I normally did with multiplication. I'm going to say this 18 is really the same as 6 times 3. And I can say that the 25 is the same as 5 times 5. And then I can do my canceling. I can say the 5 here cancels out of 5 there. 6 cancels 6, and now I can go across the top and the bottom. It looks like 5 is the only thing left on top, 3 is the only thing left on the bottom. So I would say the quotient, which is the answer to the division problem, 6/5 divided by 18/25 is this 5/3. Okay, so let's apply this same idea to division. Okay, so in this one, we have a lot of factoring to do. So I'm going to start with the first one, and we're going to factor as we rewrite. So I'm going to say in this case, x squared minus 8x plus 12. Well, I'm looking for numbers that multiply to 12 and add up to negative 8. Okay, that would be x minus 6 and x minus 2. Okay. The second one, this is a difference of two perfect squares. I can say this is 2 squared. So I can turn this into x plus 2 and x minus 2. Okay. And so the second one, because I'm dividing, I'm saying I really want to switch the spot of these two. So when I write the top one, I'm going to say let's multiply instead of divide, and I'm going to take the reciprocal. So when I factor this one, I'm going to put the work on the bottom because that's what reciprocal is. So I'm finding numbers that multiply to 18, and the same numbers add up to negative 9. Okay, so we have to think of numbers 9 times 2. Oh, it looks like 6 times 3 work. I can say this is x minus 6 and x minus 3. Okay, the top has a couple of factors, so again I like to do those off to the side. If I pull out the 2 GCF, okay, then this inside piece, this is 2 times 2 and 2 plus 2. So I can actually say this is 2 times x plus 2 times another x plus 2. Okay, and if you take a look, again I got a lot of canceling happening. Now that this is the reciprocal is taken, I can say x minus 6 with x minus 6, x minus 2 with x minus 2, x plus 2 with one of these x plus 2's only. You cannot cancel 1 on the bottom with 2 on the top. Okay, so I did all that canceling. The x minus 3 does not have a match. The x plus 2 does not have a match. The 2 does not have anything on the bottom that it can cancel with. So I'm just going to gather all this stuff and bring it along. 2 times x plus 2 is on top. X minus 3 is on the bottom. And I would say this is the quotient of those two expressions above. Okay, let's take a look at another example. Okay, so similar idea here. We're going to factor as we go. So this first one is a difference of two perfect squares. This is x squared minus 5 squared. So I'm going to say this is the same as x plus 5 and x minus 5. And I'm not flipping the first one. I'm only going to flip the second one. Okay, 4x plus 28 is linear. There's no squared here, so I can't use methods like this. The only thing I can look for is GCF, and it does have a GCF. I can say 4 times x plus 7. Okay, and now the second one is where I want to do my flip. Right, so I'm going to say the x minus 5, that's a linear term that does not factor, and there's no GCF. So I'm just going to say, well, x minus 5 ends up on the bottom. This is a quadratic trinomial, so I'm looking for things that multiply to 14 and add up to 9, and that is x plus 7 and x plus 2. Right, so again, let's take a look at our cancels here. X minus 5 with an x minus 5, x plus 7 with an x plus 7, and we are done. Right, so the bottom of this is going to be just 4, and the top is going to be the x plus 5 and the x plus 7. And again, we said you don't actually have to multiply these out and get a trinomial. You can just leave the two separate factors just being multiplied together, and this is an acceptable answer. You don't have to multiply it out. So we're going to say this is my final answer. Okay, we have one more example of dividing that we need to look at. And if you take a look at this problem, this is a complex fraction expression, and that's when we have fractions within fractions. We can call those complex fractions. So what we're saying is this little piece right here right, is a fraction, and that's the numerator of the fraction that we have right here, like that fraction bar. And then we have another fraction on the bottom, right? So we actually have fractions within fractions, okay? What I want you to remember about this type of problem is that a fraction bar is the same as a division symbol, right? If I did something like 6 over 3, that means the same thing as 6 divided by 3. So I can switch between these formats. Okay, so when you see problems that look like this, and they kind of look intimidating because we have fractions within fractions, we can take a format that looks like this, turn it into one that looks like this. So watch what we do. I'm going to take the top numerator, and I'm going to say 1 over x minus 2. Okay, 1 over x minus 2. And then the fraction bar is division. Okay, and then x plus 3 over x squared minus 4. Okay, and so this looks like the problems that we've done. So now I have to go through, and again, if you notice, not a lot of factoring happening here. The first one I'm going to leave alone. Top is just 1, the bottom doesn't factor. The second one I want it to be multiplication, so I'm going to take the reciprocal, which means x plus 3 ends up on the bottom. And I can factor this. This is x squared minus 2 squared, so it turns into x plus 2 and x minus 2. Okay, so now I can do a little canceling here. I can say I have an x minus 2 and an x minus 2. And it looks like my final answer to this is just x plus 2 over x plus 3. And again, remember, I can't cancel out part of a sum or a difference, so this x can't cancel because it's attached to 2, and this one can't cancel because it's attached to 3. We can only cancel factors, and neither of those x's is being multiplied with anything, so we're going to leave this alone and say x plus 2 over x plus 3 is my final answer.